So we have to evaluate this integral. So which property can we use here? Then what is this? Is it? And why we are going for this approach? Because you can identify some sine t by t form in this question. So sine t by t, that is always a rectangular pulse in the Fourier domain, isn't it? It is something related to rectangular pulse. Okay. So in the Fourier domain, that calculation will be easier. Now, what is this? Which property can we use? Parseval's theorem. That is 1 upon 2 pi. Okay. Now we have to find the Fourier transform of the signal x of j omega. Once we know the Fourier transform, we can use the Parseval's theorem. Tell me, what is the Fourier transform of sine square t by t? Can we use some standard result? What is sine t by t? What is sine t by t? What is the standard result?
Rect function.
Rect function. Tell me, what is the standard function? Is it sine wt by pi t? We will check the formula sheet. Is it this? 0, 1, minus 1, 1. Sorry, 0 w minus w. Sine wt by pi t is this. Let me check the formula. Yeah, it is given. Given in the formula sheet, sine wt by pi t, that is rect w by 2w. This is rect w by 2w. Rect omega by 2w. Okay. Now tell me, what is sine t by t? What is sine t by t? Is it a rectangular pulse? Hello?
With
Omega equal to 1 and amplitude is pi.
The amplitude is pi. Okay. That is sine t by t. Now sine square t by t. You can use, first you can find the Fourier transform of sine t, use the convolution property, or you can also use the multiplication, means that frequency shifting property, isn't it? This is, let's say, this is sine square t by t is equal to e to the power j isn't it? This is x of j omega. Tell me, what is x of j omega? This is sine t by t. Fourier transform is this. This is function of omega. Now what is sine square t by t? What is the effect of multiplying with e to the power jt? This will be
left by 1. Or shift to the right by 1.
shift to the right by 1. This is shift to the left by 1. And there is 1 by 2j. Okay. And that is x of j omega. Isn't it? So this will be shifted right by 1. That is this. And shifted left by, this is 0 to shifted left by 1.
It's a negative sign.
Negative side. But we, in the Parseval's theorem, we are taking magnitude of x of j omega, isn't it? Is it? We don't need, if you want to sketch it, the actual value is something like this. Shifted right by 1. This is what is the amplitude? There is pi here. This is pi by
Pi by
2 into 1 by 2 by j, isn't it? That amplitude, is it? And here it is pi by 2 into minus 2 by j. And if you sketch the magnitude of x of j omega, then what will be is it the magnitude of x of j omega? Is it the magnitude?
yes, sir.
This is 2 minus 2. What is this value? But what is the amplitude? What is the magnitude of this?
Pi.
Pi.
So it should be pi by 2.
Pi by 2. What is wrong? Missing
So
something.
1 by j.
Mm-hmm.
So it should be 1 by j instead of 2 by j.
Yeah, it is 1 by j. So it is pi by j. So the magnitude is pi by 2, isn't it? This magnitude is pi by 2 from minus 2 to 2. Now tell me what is the answer? This is magnitude of x j omega. Now Parseval's theorem says that this is equal to 1 upon 2 pi minus infinity to infinity magnitude of x j omega square d omega, isn't it? What is that? But this is pi by 2. This is from minus 2 to 2.
So it comes out to be pi by 2.
It is pi by 2. Okay. It is pi by 2. Okay. This is given. Fourier transform of a signal is given. The first part is xt periodic? Is it a periodic signal? xt. Is it a periodic signal? How to check whether it is a periodic? What is xt here? This is the standard result. 1 Fourier transform 1 is 2 pi delta omega. Now what is xt? xt is what? We can use the linearity property. What is the inverse Fourier transform of this part? Delta omega?
1 by 2 pi.
1 by 2 pi plus what? What is
E to the
inverse?
power j pi t.
To the power j pi or minus j pi? Is j pi or j pi t?
J pi t.
J pi t. And next one is e to the power minus j phi t. Okay, that is isn't it? That is inverse Fourier transform. Is it a periodic signal? Is
So
it a,
shouldn't it be plus j5 because omega minus 5?
which one? But this is plus phi t. J phi t. Is it a periodic signal?
Yes, sir.
Yes. What is the fundamental period? What is the period of this?
2.
Is it periodic with period 2? What about this?
2 pi by 5.
2 pi by 5. Okay. And this is a constant signal. Constant, isn't it? 1 by 2 pi. So what is the period? This is periodic with period. What?
But
Period 1. What is the LCM of these two?
It's not periodic.
It is not a periodic signal. But is the condition for periodicity?
MT1 is equal to NT2. NM are integers.
Hmm. So it is not a rational multiple, isn't it? So is it a periodic? This is not a periodic signal. Okay. So this is an aperiodic signal. Now, what will happen if you multiply a convolve with HT? What is the convolution property if you convolve with HT? It is multiplication in the frequency domain, isn't it? Is it?
Yes, sir.
What is h of j omega? What is this signal? This is 0. ut minus 2 means this is a signal HT. 0, 2. Now tell me, using the standard result, what is the using the standard result, what is the Fourier transform of this? It is a rectangular pulse, standard rec function shifted right by 1. Is it? Not standard rec function, it is rec function of width 2. Okay, width 2. It is not a standard rec function. So tell me, what is the Fourier transform of this? Where is the result? It is 2. Here T1, is it rec function is 2 sine, here T1 is 1, 2 sine omega by omega into e to the power. Is it the Fourier transform?
Yes, sir.
Now let's say yt is equal to xt convolution ht. What about y of j omega? Y of j omega? You have to multiply these two, isn't it? Is it? Can you find yt, y of j omega? What about the first term? When you multiply this with delta omega, what is the resulting signal? Sorry?
2.
It is not 2 into delta omega. Is it? Is it 2 into delta omega?
Yes, sir.
Because this is non-zero only at omega equals to 0. At omega equal to 0, the value of this function is 2. So it is 2 into delta omega plus what?
0.
Plus 0, because the value of this function at omega is equal to pi is 0. Plus what? Sorry, not plus, minus 2 sine 5 by 5 into e to the power minus j 5, because omega is equal to 5 into delta omega minus 5. Is it this?
Yes, sir.
Yes.
What is inverse Fourier transform? And here you don't need to find the inverse Fourier transform. From this itself, you can directly say that argue that it is a periodic signal, because this is why this was not periodic. The inverse, the signal xt was, why it was not periodic? It is sum of these two signals, right? Now, if you remove one of those, will it be a periodic signal?
Yes, sir.
It is a
Sure.
periodic signal. You can find what is the fundamental period of this signal, yt? What is the fundamental period?
2 pi by 5.
It is 2 pi by 5. Okay. So the xt convolution ht is a periodic signal with fundamental period 2 pi.